Okay. So you have to know the population standard deviation. Which is sigma. Here you know the sample standard deviation. This one you're going to use A16. This one you're going to use A18. And the only difference in the formulas is this one's x bar minus mu divided by sigma divided by the squared of n. And this one is x bar minus mu over s divided by the square root of n. So really, it's almost the exact same process. The only difference is the chart you're using, essentially. All right, so make sure you have that T-chart out in front of you. Do you remember when we were doing confidence intervals that we used, if you look at the top of the T-chart, there's like that level of confidence thing, right? 80%, 90%, 95, 98, 99. And now, remember how there was like that one tail and two tails thing, and I was like, ignore it, don't pay attention to it, doesn't matter right now. Now you're like, oh, one tail, two tails. Okay, I understand what you're saying. So the only difference is for a one tail test, you're going to use whatever's in that one tail column. If it's a left, you're going to add a negative. If it's a right tail test, you're going to keep it positive. And if it's two-tailed, you're going to use this two-tailed column and make it positive and negative. Which kind of makes sense. Because if there's, everybody look up, if there's 20% in two tails, what percent is there in one tail then? In each tail? 10. So you see how they're like on the same line together? All right. Do you remember what degree of freedom is? N minus 1, yep. Just one less than n. All right, so let's start by doing the null and alternative hypothesis. A used car dealership says that the mean price of a 2-year-old sedan in good condition is $20,500. You suspect this claim is incorrect and find that a random sample of 14 similar vehicles have a mean price of $19,850 and a standard deviation of $1,084. Is there enough evidence to reject the dealer's claim at alpha equals 5%? Assume the population is normally distributed. Okay, so we got a mu and a mu. We see that it's normal. Now, you notice how it doesn't say whether we know sigma? It just says standard deviation. How do you know if that's a population standard deviation or a sample standard deviation? Well, they're talking about cars, and they're specifically talking about this sample of cars, right? And they say when they did this sample, they found this and this. That's a sample standard deviation. It will be called they rarely say the word sample standard deviation, but they always say population standard deviation when it's a population standard deviation, so. Also, it's this section, so you know it's probably gonna be sample the whole time. All right, so mu is, let's see, you say, oh, this is their claim. They claim that the mean price is $20,500. This is their claim. Alternative is that it's not equal to. All right, what test should we use? Left, right, or two-tailed? Two-tailed. Level of significance, it says right here that alpha is 0.05. Degree of freedom. What's our degree of freedom? 13, because 14 is n. All right, I'm going to draw a picture down here. Two-tailed test. All right, so you're going to go on your T chart and go down to 13 for degree of freedom. And then on the top, you're picking two tails, and we're picking 5% confidence, which is that middle column. Did you guys get 2.16? Okay, so this is negative 2.16, and this is positive 2.16. So that was step 3. T-test is x bar minus mu over s divided by the square root of n. So let's see, when they did their test, they found that their mean was 19,850 minus mu, which is 20,500, divided by s, 1,084, divided by the square root of 14. Make sure you put parentheses on the top and the bottom. Oh. I do not know where my calculator is. That's weird. Okay. Well, that bothers me a lot.
Is it sitting on my desk by chance?
Sitting on your desk?
When I walked in, and then I put it back here because I didn't want to.
Yes. That's it. All right. I'm guessing Penny took it this morning because she likes to write messages on my calculator. And I'm guessing she's the one who wrote, ah, on my calculator. Did you guys get negative 2.24? All right, so negative 2.24 is our standardized test statistic. So what do we do? Accept or reject? The null.
Okay.
Reject, because it's in the rejection regions. So reject the null. And what does that mean about the claim this time?